Alright, welcome to the video on section 10.4, which is going to be inscribed angles and polygons. Okay? We've talked about the word inscribed a little bit. Inscribed means to be put inside. There's probably better formal definitions, but that one will work for our purposes. Okay? So these will all be angles that are enclosed within a circle, like this picture right here, or these two angles down here. They're angles that are inside of the circle, so they're called inscribed. Okay, so I guess here's our technical definition: is going to be an angle whose vertex is put right here. I'll also highlight this. An angle whose vertex is on a circle and whose sides contain chords of the circle. So, vertex is on the circle. Sides are chords on the circle. The measure of an inscribed angle is exactly half the measure of its intercepted arc. We're not going to prove it here, but that means is that the measure of angle E. The measure of the inscribed angle, we can call it angle E or angle DEF, either is fine, is half of the intercepted arc. So this is going to equal 1/2 of the measure of arc DF, which is this little arc right here. So this angle right here, this little tiny one right there, is 1/2 of whatever this measures. Okay, that's how we're going to use that a lot. So this is our very important theorem, if you will. There's going to be 3 different ones to start with. We have a bunch this section. My paper just moved. Okay. So that's how we're going to start the section, is that one right there. Okay. The next one is going to be that if we have 2 angles and they intercept the same arc, they are congruent. So if you look at angle 1 here, angle 1 goes through this point right here and this point right here. If you extended angle 1 out, it would touch these 2 points. So the arc that it intercepts is from here to here, right? I'll even highlight that. Okay. The arc it intercepts is right there. Now, looking at angle 2, it's in a different spot. It's a different angle. However, it intercepts the exact same arc. Okay? And so if they intercept the same arc, then those 2 angles are congruent. So there's the second formula we'll have here. If they intercept the same arc, they're congruent. And the last one is if we happen to have a quadrilateral that is inscribed in a circle, so it is enclosed in a circle, then its opposite angles are supplementary. The opposite angles on the quadrilateral are supplementary. I'm going to highlight that. Okay? Opposite angles. So that means that A and C make 180 and B and D make 180. Okay? So there's the 3 things we're going to use for the start of this. We'll do a few examples, but we'll have that just these 3 things here. I'll call them 1, 2, and 3 for your notes so that we can go back and refer to it. If I say, hey, this is our theorem 1, I'm going to talk about this. Theorem 2, talking about this. Okay? So on to page 2. I have some examples I'll use this to cover. So example 1 here. We have 17 degrees that belongs right here, and it wants to know what x is. Remember, the measure of this angle is equal to 1/2 the measure of the arc. So set that up. We know that 17 is equal to 1/2 the measure of the arc. Well, the arc is measured 0, or it's not 0, x, excuse me. So we have 17 equals 1/2 x. That's using theorem number 1 from the previous page. Okay, all you have to do to solve that, take it times 2, and you get x equals 34. That'll be your final answer there. Okay, not too terribly difficult. Number 2, exact same thing. Use theorem number 1. The inscribed angle is 1/2 of the intercepted arc. Excuse me. So we know that the inscribed angle 3x is equal to 1/2 of the arc, which is 138 degrees. Okay. So now we take 138 divided by 2, or times 1/2, however you look at that. We get 3x equals 69, divide by 3, and we get x equals 23. That would be our final answer there. Okay? So overall, using theorem 1, not too terribly challenging, right? These angles have to be inscribed, so they have to be on the edge of the circle, with these 2 being chords. But once you have that, not too terribly challenging to work with. Okay? Example number 3. 3 and 4. We're going to use that second one. Remember, if the 2 angles intercept the same arc, then they are congruent. So if you look at x and 50 here, do you see how their edges come to this point right here and this point right here? So they actually both intersect, or intercept, however you want to say that arc right there. So that's theorem number 2. If they intercept the same arc, they are congruent. So we would just say that x is equal to 50. And that would be our problem. Okay? On to number 4. Looking at the same thing, right? They both go through this arc outside here. This one right here. Okay. So again, they're congruent. So we have 3x plus 5 is equal to 80. Subtract 5, and you get 75. Divide by 3, and you get 25. Okay? Some teachers call these bow tie problems for obvious reasons. So if you ever heard there are some geometry problems called bow tie problems, you'll see these. Okay? So that's theorem number 2. So these used up here. These used theorem 1, and these two used theorem 2. We can guess what this one's going to use. Okay? It's actually going to use a little bit of all of it. We actually have a quadrilateral in there, a little bit inscribed. We have 2 triangles inscribed. We actually have a couple of those bow ties right there, and then we have intercepted angles. So it's not too terribly bad. So let's just start out with what we're given. We have WX, that arc is 104, and we have WZ is 88. And the measure of angle ZWY, so ZWY, angle 2 there is 26. So I'll put the blue things, those are the givens in the problem. And we want to find the measure of each angle. Let's go ahead and just do the rest of it to what we can on the outside of the circle. So looking at 26 degrees here, if this is an inscribed angle, ZWY, then we can certainly find ZY, right? Because theorem 1 says that the arc is twice the size, or the angle inside is 1/2. So 26, let's put an X here. Put an X there. 26 is 1/2 of that outside arc. Okay, that means that X right there is equal to 52. So that right there is 52 degrees. Let me cross out that X. Okay? We're not going to even talk about these yet. We're just going to get all the way around the outside. So now we have 3 pieces of the arc. We only have 1 left. Remember, circles always add up to 360. So all I'm going to do is, I'll do this in red, I'm going to take 360 minus 52 minus 88 minus 104, and that's going to give us yx. Okay, so 360 minus 52 minus 88 minus 104, we get 116. Okay, so this right here is 116. So now we actually have all of the outside things, and we can start talking about the angles. So angle 1, can we do that one yet? We sure can. Angle 1 intercepts 104, right? If you look at where angle 1 goes to, it goes to W and X, so the arc it intercepts is 104. So remember, the angle is 1/2 of the arc, so we would do 1/2 of 104, which would be 52 degrees. Okay? That's how we're going to kind of go through all of these. Okay, angle 2. Angle 2 is 26. That one's given to us, right? DWY. That's 26 degrees. On to angle 3. Angle 3 is right here. Now that intercepts 116. See, that goes to Y and X. So it would be 1/2 of 116. So that would be, what is that? 58? 58. I don't know. I doubt myself. 58 for angle 3. Okay. Angle 4. Angle 4 is right here. It intercepts 88, so it would be 1/2 of 88. At a certain point, you get the hang of it, right? 44 degrees. Go ahead and do angle 5 and 6 on your own. Please pause me and do it. I'll give you, that time. Okay. Angle 5, it's going to be 1/2 of 52, like you just did. So that's 26. Or you can look that angle 2 and angle 5 intercept the same arc, and so they're the same measure. Okay, and angle 6, we'll use that fact. Angle 1 and angle 6 intercept the same arc, so angle 1 and angle 6 are the same. So that one's 52 degrees. And I'm going to write same as the measure of angle 1. Okay? That's using theorem 2. All right, on to the last page. We have some inscribed stuff here, and we can talk about a little bit of it. So number 6, we have an inscribed quadrilateral. Remember, theorem 3 says the opposite angles are supplementary. That means that y plus 120 is equal to 180, and z plus 80 is equal to 180. So pretty simple. Y is 60, comma, z is 100. Okay? That's all you need there. You need that theorem 3. Okay? On to number 7. We have kind of a cool problem here. I never told you about inscribed triangles, right? but we have kind of just 3 inscribed angles, if you will, and so we're going to use the arcs a lot. So if this arc right here, if this angle right here is 40, remember the angle is 1/2 the arc, so the arc's twice the size. So that arc is going to be 80. Now you can see right here, MK is a chord that goes through the center, which would make that a diameter. And diameters cut the circle right in half. So this whole thing right here is going to be 180 degrees. This M to K, that's a semicircle. Okay? Or M, the opposite of L, okay, whatever it is. So that means that LM, that last piece, is going to be 360 minus 180 minus 80, which would be 100. Okay? And so now we have all 3 pieces. Remember, the arcs on the outside are twice the size of the inside. So if this is 180, that means that X is 90. Okay? And if this is 100, Y is 50. That's just using theorem number 1. And our knowledge of arcs. And the last one for 10.4 says find the measure of arc VG and then find the question mark. So let's find VG first. Okay? To find VG, notice this right here and this right here is VG, and that goes to this angle right here. So that means that that arc right there is actually twice the size of 65, which would be 130, I believe. So VG, measure of arc, VG is 130. Okay, I'm going to put a little bracket there and put 130. Okay? Now to find the question mark, we're actually going to need to find this piece right here. If we had this piece right here, FG, then we could take 130 minus FG, and we would get just VF, and we would be good to go. And so what we're going to do is we're going to notice that if we had FH, we could take FH, or FGH, this whole big thing, and we could subtract off GH, or the 168, and we'd have FG, and we'd be good to go. And so to find this piece right here, FH, we just notice that F and H go to this angle right here, 119. So if we take 119 times 2, that tells us that this whole big arc on the outside here, this whole big thing, is 238. Okay, and as we just said, to get FG, we're going to take 238, that whole thing, minus this piece right here, so minus 168, and that tells us that FG is just 70. So 70 goes right here. Okay? And to finish out the problem, if we take our whole VG, our whole 130, so we want VF, that's our question mark, VF is going to be the whole thing, 130 minus FG, which is 70, and that'll give us 60. So the question mark is equal to 60 degrees. Okay? A little more involved problem, but not too terribly challenging once you understand how to work with the arcs. Okay? We have one more video for this week. We have 10.5. No school on Friday, so enjoy your time off. Go ahead and have a great day.